Hello and welcome back to the channel. I'm going to start doing a different format for a few weeks and see how that goes. And basically the format's going to be solving these live as opposed to doing them ahead of time and giving you like a scripted description. Because I think it'll give you a better feel of like what it's actually like to solve a problem in real time, what you look for, things like that. Because if I solve it like ahead of time and give you a scripted description with like no errors, maybe I won't describe it enough and things like that. So I'm going to try this format and you guys can let me know how it goes. So in this one, we're going to do find the power of k-size subarrays. And I did do this problem actually like 5 months ago or something, but I don't remember it. So it'll basically be like doing it again because I do so many problems. So in this one, you're given an array of integers nums of length n and a positive integer k. The power of an array is defined as the maximum element of all its elements that are consecutive and sorted in ascending order. So right away, this tells you basically the array is sorted in ascending order. So the maximum element is always just going to be the rightmost element, and -1 otherwise. So I guess if the array is not sorted, you'll get -1. You need to find the power of all subarrays of nums of size k. So subarrays is contiguous. That's important. Return an integer array result of size n minus k plus 1, where result I is the power of I to I plus k minus 1. Okay. So it looks like they do some stuff here. So the first element for this, it's 1, 2, 3. Okay, so it looks like for every index, you basically say like what's the array of length k starting at that index, and then you either return the max if it's sorted or -1 if it's not. So like here, this is the first element, so you just get 3. Then at the second index, it would be 4. Third index is not sorted, so -1, -1, -1. Yeah. And then, okay, it also has to be consecutive. Oh, it's okay, so that's another thing. So they have to be consecutive. So they can't just be increasing, they have to be consecutive, meaning you have to have like 1, 2, 3, 4. You can't have like 2, 2, 2, 2 or something. They have to be increasing and in consecutive order. So yeah. Okay. Okay, so here, this first array is this, so that's not consecutive. I mean, none of these are consecutive, so then here, case 2, this is not increasing and not consecutive, so -1. This is 3, not, so -1 is 3 and is not. Okay, so the nums length is short, so you can do something pretty bad. You can do like n squared or something, but because the array is consecutive, or not consecutive, it's subarrays, we can probably just like figure out a way to smartly record like subarrays in some way, and then just check if it's increasing or not. So like if we have something like let's say this, and then let's say our next number is non-increasing, basically we can kind of treat this as like a newer array, because if this is not consecutive, then like nothing containing this is consecutive, right? If there are more things here, like if I just took any chunk here, nothing including both of these would be consecutive. So we can kind of just like break into a new array every time we get a non-consecutive solution, essentially. So we can basically just like go through this array and keep building it up. And then if we need to move it over, we can do that too. We can just like get rid of the smallest element and add the biggest element and just keep checking for this consecutive nature in some way. And as soon as it's not consecutive, we can just say like, let's start a new array here. And then somehow we'll put in the results. So some kind of sliding window type thing, maybe even simpler than that. So let's just make a new array of this length and fill everything with -1, I guess. Start with that. So, and yeah, I think the idea is going to be using some kind of sliding window here to just maintain like, are we still consecutive or not? And if we are still consecutive, we'll just output like the current element we're at, basically, is going to be the idea. Also, another thing that I'm thinking is, yeah, so the other thing, if you notice, or actually, I don't know if there is an example of that, actually. We can try to do it, though. So I am curious what we need to output if we get, let's make another test case. And let's say we get 3, 4, 5, 6, 7 in case 3. Because the thing I really want to, it's not really super clear here, is like, let's say we're at this index, like we don't actually have 3 numbers. So should we just always return -1 when we don't have enough numbers? So let's just return like yeah, we'll return something here, and then let's test for this case. Okay, so this is going to be num's length, and then I think it's like arrays fill, something like this. We'll turn this on, and then we can return that result array and see what we get in this test case. Oh, okay. Okay. So basically, so this is actually not going to be num's length. We're only going to make it the length of like elements where you can actually have like a full array. So here you can have 3, but here you can't. So this is not going to be num's length. This is going to be num's, I think they might tell you even. Yeah, n minus k plus 1. So that's my answer to that. Okay. And so I think the plan is, like if we have some example of some array, like 1, 2, 3, 4, 5, whatever, we're just going to build like this window. And then whenever a window is of size k and increasing, then we'll just check like what's the leftmost index here. And that will be the spot we fill in. So for example, if this k is 1, 2, 3, 4, 5, 6, then, and k is, or this index is 6 and k is 3, then we're going to fill this element. This is going to be index 4. So the index we're going to fill in is going to be index minus k plus 1, I think. Something like that. Yeah. So this thing. Okay. So let's just go through the array and let's just keep track of, I guess a simpler way would be, we can just keep track of like how many increasing numbers in a row do we even have. So what this is going to look like, just to do a quick dry run of this guy. And I'm not going to try to use Excalidraw as well, because like in a real coding thing, you can't use it. So we're going to try to limit the things we use here. So basically in the beginning, you only have one element. So you just say like, it is increasing and the streak is 1. And then here you have 2 elements. So it is increasing, streak is 2. Then here it's increasing, streak is 3. And then as long as, anytime the streak is k, then you just mark the element at this guy to the element we're currently at. And then whenever we break the streak, we'll just like reset it. Yeah, I think that should be fine. So I think it's gonna be very simple. Okay, so let's just go through, we don't even need like a 2-pointer, we can just have a for loop. And we're basically just gonna have a variable of like current increasing streak. So we can just call this like streak. And then here, yeah, can k be like 0? No, okay. So we can say, we can check if our streak is increasing. So we can say like, if I is 0, because there's no element before this one, or nums I. Actually, yeah, we do need to go to k. Yeah, we do need to go, or we do need to go to the end. So this is just I equals nums I minus 1 plus 1, right? So we do have this like streak thing. So if this is the case, then our streak will increase. Otherwise, we will reset the streak. Yeah, sure. And if we say, if the streak is k, then like if we have some streak equals k, then the element we need to set is going to be the first index of that streak, and it's always going to be unique, right? Like if this is k, if here the streak is k, we're always going to be setting this index here and so on. So we don't need any pointers or anything. So this is just going to be a result of this guy here. So actually it's not going to be I plus k because we're already at the end. So it's going to be I minus k plus 1. All right, because like if we're here, we have these 3 elements, and this is the index we want to record. So if this is 1, 2, 3, 4, then this would be 2 is the one we want to record. So we just mark this as the current number because whatever number we're on is always the max of that whole like window. So this should just be nums I. Yeah, and then we just return. Let's see what we get. Okay. Index out of bounds. Okay. Oh, this is this. Okay, got something wrong again. So let's see, try debug. Okay, so so the streak can be bigger than k, which is fine too. So that's fine. Okay. Right, because if the whole array is increasing, the streak will be bigger. Okay, nice. Yeah, so hopefully that makes sense. Let me know what you think of this format. But I think this is going to be like kind of, you're going to be able to see kind of how I solve problems. It'll be a little bit messier, but it'll be more realistic. Yeah, and so here we're basically doing this, like keeping track of increasing streaks. That's linear, space 0. We didn't even need literally like a sliding window. Kind of figured out a non-sliding, I mean, it's still kind of a sliding window, but yeah, I kind of figured out a simple solution. Just maintain an increasing streak. Whenever an increasing streak is k or more, we can just we know like where that window starts, and we can just mark that element and leave everything else as -1. Okay, so that's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel. Let me know what you think about this format, so on. And I'll see you in the next one. Thanks for watching.